Hello, this is Mr. Stansbury. I'm going to take you through the 17D notes on higher order rational functions. Okay, so at the end of this, you should be able to say I can find x-intercepts, y-intercepts, local minimums, local maximums, and graph more complex rational functions. All right, so first thing we're going to do is we're going to take a look at investigation 6 from page 563. All right, so it's basically just going to have us take a look at a couple different types of rational functions here. Okay, so it's going to have us look at a linear function divided by a quadratic function, and then a quadratic over a quadratic. All right, so linear meaning it's like the power of x is just 1. So first power, and then quadratic, the power of x is 2, x squared, x times x is x squared, and then there's x squared. All right, so let's make this relatively, hopefully quick and painless. I've got these all entered in on the graph program. So I figured let's take a quick look at these. Okay, so here's the first one, x plus 2 divided by x plus 2 quantity squared. So that looks like this here. And here's our vertical asymptote here at x equals 2, which would hopefully make sense because 2 minus 2 gives us 0, so it can't be here at 2. All right. And then this here is going to have, it's hard to kind of tell here, but it looks like it's going to actually have a minimum somewhere in here, and that's going to come back up, whereas this one's going to just kind of keep on going down. So this one's got a minimum, but no maximum. All right, next one to look at is this one here. So similar, except for it's got this little deal down here as well. Okay, so if you'll notice here, this is actually going to have two asymptotes. One at x minus 1, so 1. So there's an asymptote here at 1, and there's also going to be an asymptote at 3, because again, it can't. Neither one of those can equal 0 because you end up dividing by 0. Okay. So we're going to have a maximum here, and again, it looks like we might have a minimum over here, and it looks like that one's not going to have a minimum value at all on that curve. So in other words, this one looks like it might go down and then come back up. We'll have to take a look. We're going to take a closer look at these on the graphing calculator. All right, and then the third linear one is this. It just comes down here, and it has a little bump, and then it comes back down again. All right, so those are 3 linear. And then here's a quadratic divided by a quadratic, and it's just a big fat mess here. So it's got this here, it's got this little bump down here, and then it has this where it goes down, and then it comes back up. All right, so just kind of a quick glance at these. You will not be expected to graph these by hand. That would be, it's doable, but it's not very pleasant. We're going to use our graphing calculators a bunch on this. Okay, here's the next one, some kind of goofy looking graph there, and then here's another one that they have us do, and again that's going to have some minimum. Well, it's obviously got a minimum here. It's going to have a maximum on one of these sides here, another. And then the last one is this one, kind of similar to that. I think the first one we looked at. Yeah, somewhat similar-ish. All right, so that's roughly what those all look like. Let's take a closer look at just one example. We're not going to look at every one of those. That would be long and painful. So let's just take a look at one of these, and I'm going to teach you how to use the graphing calculator to figure this out. So for the function y equals x plus 3 over x squared minus 1, use technology to observe the function. So we're going to use our graphing calculator. All right, so let's turn this thing on, and y equals, because we're going to plot, right? And then we want x plus 3, so I'm going to put that in parentheses. So we got x plus 3, all in parentheses, divided by x squared minus 1, all in parentheses. So parentheses, x squared minus 1. Close those parentheses there, and we get this here. And we hit graph, and we get that funky looking thing here. So says use technology to observe the function. Here's technology. We're taking a look at the function. There's nothing really to write down on that. Okay, draw a sketch without plotting the points. So really it's just going to be, we're just going to kind of sketch this here, which is, gosh, I guess we'll just, oops. We're just going to kind of, again, sketch that in. That looks like it's just on the other side of 1. So it comes down here. Kind of looks like that. And then looks like at about 3 or so. So it kind of comes up like this, something-ish. And then the other side here does a similar type thing. Does it go down below? Can't really tell. So it looks something like that. Okay, so there's our awful sketch. Find the axes intercepts, okay? So with that, we are going to have to figure out when y equals 0 and when x equals 0. So to find the x-intercept, we know these x-intercepts, we know that y equals 0. So let's try that one first. That's the harder one, usually. So 0 equals x plus 3 over x squared minus 1. Okay, so I'll just do that as 0 over 1. So those cross multiply and they turn into 0. So it's basically just x plus 3. X plus 3 equals 0. So subtract 3 from both sides. And x equals negative 3. So axes intercept, we got x equals negative 3 is one of them. So right here, which obviously did not quite hit on my graph. Let's see if it looks 1, 2. Yeah, so it's going to be right there. So maybe we could zoom in a little bit and see if that, I don't know if that's even going to work. Oh, there it is. Of course you can't tell, but yeah, it looks like it's coming down over there. I'm going to go back out. I'm just going to go back to zoom standard and it'll get us back to that graph there, our original one. All right, next thing, let's find out when the when x equals 0. We'll figure out that's going to be our y-intercept. All right, so y equals 0 plus 3 all over 0 squared minus 1. So y equals 3 over negative 1. So we got x-intercept is negative 3 and y-intercept happens to be negative 3 as well. At least we got that one right. Okay, so those are two intercepts. Okay, find any local maximums or minimums. So this is the tricky part. Well, it can be. This maximum here, no big deal. We can find that one pretty easy. So that one's the easy one. Let's figure that out first. So let's do second calculate and we'll do the maximum. Okay, so we'll go to the left of the maximum, push enter, go up to the right of the maximum, push enter, and it's going to give our maximum at negative 0.17 and 2.91. So that's a max at, let's see, let's do that back with green. So max is negative 0.17 and negative 2.91, I think it was. Yeah. Okay, so there's our max. Now, one of these two sides is probably going to go down and then come back up just a little bit. All right, and it can't really tell which side it is, so we just kind of have to guess. I'm thinking it's this side over here. I think it's going to come down through 3 and it's going to come back up. So there's actually a pretty nice way to tell. Well, first what we'll do is we'll just go through and we're going to calculate. We're going to try to find the minimum on that. Okay, and again on this side, this one it looks like it's going to be the left side. Oops, so I'm going to keep going here. One nice thing to look at is you can look at the x. X right now is negative 1.7. Sorry, look at the y, 0.68. And as I go to the left, it's going down, down, down. What I want to look for is to see if this number starts coming back up at any point. 0.08, 0.35, 0.002, negative 0.5, 0.67, 0.849, 0.855, 857. Ah, look, now it's going back up. Negative 0.083. It was just at negative 0.085 something. So there is a minimum in here somewhere. So I know I'm to the left of it, so I'll push enter. I'm just going to get back over here. That's far enough over because, again, I'm back above where I was before. Push enter again, and there's a minimum at negative 5.83. So let's see, we got a minimum negative 5.83 and negative 0.9. Negative 0.09, right? Yeah. All right, so there's our max, there's our minimum. All right, and then last thing says add the above features to your graph. So you're going to want to actually add these features on here. So make a little dot here, and I'm going to put, let's see, this is negative 0.17 and negative 2.91. And then I'm going to want to put over here this point as well. I'm going to want to label this too. This is a max. Oops. And it's a considered a local maximum, but we'll just go for maximum for now. And then this one over here. Here, let's put that in a color that you guys can actually read. Okay, so right here there's a maximum at negative 0.17 and negative 2.91, and then over here it's a minimum at negative 5.83 and negative 0.09. Okay, so again, it's all on the graphing calculator that you can calculate these things. You don't have to find them by hand. We'll just use our technology. All right, and then we're good to go. All right, that is the second and last example. So now you should be able to say I can find x-intercepts, y-intercepts, local minimums, local maximums, and graph more complex rational functions with the help of our handy-dandy graphing calculator. All right, if you have any questions, please ask. Thanks.